Now to question for June 2021. Says the diagram below shows two lines, L1 and L2. The equation of L1 is x plus 2y is equal to 10. And the line 2 passes through the point 0, -5, and is perpendicular to L1. What do we know about the gradient, the product of the gradient of perpendicular lines? Let me see if anyone know that. That's something important that you should know. Yes, they are reciprocal, but very good, -1. So when we work out the product of perpendicular lines, it will give us an answer of -1, and that should be helpful, and everyone should know that. That is something that you should know going into exam. So part 1 says, express the equation of the line L1 in the form y is equal to mx plus c, and we know that y is equal to mx plus c is equation of a straight line. All right, let's see. A half. There's no x in that formula, so we know. And Selena needs to check her answer. But so if we have y is equal to mx plus c, very good. So our equation is x plus 2y is equal to 10. So we're making y the subject of the formula. So the first thing that we're moving is our x. So our x is positive here, so when it comes across, it is negative. So we're subtracting x from both sides of our equation. So it is minus x plus 10. Now we're moving the y, it is multiplying here. So when it comes across, it will be dividing, or it's the same as we're dividing both sides of the equation by 2. So y is equal to negative x plus 10, all of that being divided by 2, which when you work it out, what we basically have.
So why put negative x plus 10 to the 10 take away x?
Because we're writing it in the form y is equal to mx plus c. So 10 is c, x is x, and this 2 coming over is basically a half, which is our gradient. So y is equal to minus a half x plus 10 over 2, which is 5, and that is how they got 5 there. So now when we simplify it, we'll get y is equal to minus a half x plus 5. So 10 divided by 2, and that is how we got 5 there. So our answer is minus a half x plus 5. Any questions from this? All right, so that is our equation for L1 in the form y is equal to mx plus c. Part 2 now says, state the gradient of L1. Easy question. I told you that this paper wasn't easy. Y negative x, remember we're transposing, and when the x here in the original equation, it was positive. So remember, in order to get rid of it, when it's going across the equal sign, it becomes a negative x. It's the same as we were subtracting x from both sides of the equation. Follow me, Sims? Get me? So it was positive on the left-hand side. So when it go across, it becomes a negative x. No problem. All right. So I'm seeing, I think I saw someone said the gradient was 2.
Yes, sir, the paper wasn't easy.
No, I said the paper wasn't hard. The paper was easy. It was just long. I think that was the problem. The paper was long, but it wasn't difficult. Because this question, it says, state the gradient of the line. You'd have already know this y is equal to mx plus c. From this, m is our gradient. The equation is already in the form. So therefore, all you're doing is picking up what the gradient is. So you're saying m is equal to minus a half. And that is our answer. So therefore, m is equal to negative a half. Sir, could you go back over the equation of the line? No, Selena. So Kyle, it will, no, it's not always a half. This equation, x plus 2y is equal to 10. It was given in the question. X plus 2y is equal to 10. Equation of a straight line, general formula is y is equal to mx plus c. They ask you to rewrite this formula in this format. So all that we were doing is to make y the subject of the formula from x plus 2y is equal to 10. So first, we move the x. It was a positive x here, so when it comes across the equal sign, it becomes a negative x. And that is how we know have 2y is equal to negative x plus 10. What we need to move next is the 2 because it is on the y, and what we want is y to be the subject of the formula. So the 2 is multiplying here, so when it comes across, it will be dividing, or it's the same as we're dividing both sides of our equation by 2. And that is how we now have, this is the same as minus a half x plus 10 over 2, because remember, both terms at top, they're sharing this common denominator, which is 2. So it is a half x plus 10 over 2. All we did was to simplify the 10 over 2 because it can be simplified. And one thing we learned in mathematics from section 1 of our syllabus is that once it can be simplified, you go ahead and simplify. So that is how we get y is equal to minus a half x plus 5. Can be the same as y is equal to minus x over 2 plus 5. It's the same thing. So the reason why we divide by 2 is because we want it to be simplified, right? So it should just be y and not 2y, 3y, or 3y. But if you didn't do that and instead you just use it, not that it would be wrong, but in this case, more than likely it will be because they ask you to express it in this format. But you will see straight line equation where you'll have like 3y is equal to whatever plus c or that kind of stuff. But in this case, they're asked to write it full out representing straight line. Kyle, we got negative a half because remember, this is negative x over 2. This is the same as minus 1x over 2. Minus 1 over 2. That is how we got minus a half. Because remember, minus x is the same as minus 1x. Very good, Renisa. So minus x is the same as minus 1x. So this is basically saying minus 1x over 2, which is the same as minus a half x. Minus 1x over 2.
Sure, that's it.
Minus a half x. Sir, if it's that form, then we could get rid of the coefficient in front of the y. So that is how we got rid of the 2 and brought it across, and that is how the right hand side started being divided by 2 because we got rid of the coefficient. And this is our equation in its full form, y is equal to minus a half x plus 5. Then it says state the gradient of the line. So we know that from our formula, m is representative of our gradient. So all we looked at is what value is in the gradient position, and that is how we got minus a half here. Part 3 now says, hence determine the equation of the line L2. So they want us to determine the equation of the line L2, and someone says, Selena says 2x minus 5. Very good. So first things first, what is our gradient for L2? For line 2, what is our gradient? 2, because it is the reciprocal of the other line, the other gradient, the positive, or you're basically multiplying the reciprocate your previous gradient while multiplying it by -1. So if we have -1/2, you're doing 2/1 being multiplied by negative. So that's how it basically became +2. And so our gradient is m, or gradient is 2 for this line. And we're putting it in the form y is equal to mx plus c. And if you remember, the question above told us where line 2 cuts the y-axis. They said it's 0, -5. So our x-axis is 0, or y-axis is -5. We're going to use that to find what the y-intercept is, which we could also know from just looking at those, because if they gave us where it cuts the y-axis, remember the y-intercept is where the line cuts the y-axis. So basically we know what c is, but for those who probably decide still to work it out, our y value was -5 is equal to our gradient of 2, or x value of 0, because remember it was 0, -5 plus c. Very good. And what we'll get is -5 is equal to 2 times 0 is 0 plus c. So therefore, -5 is equal to c. And we can now put this into the format of y is equal to mx plus c. So therefore, y is equal to our gradient of 2 being multiplied by x minus c, which is -5. And that is our answer. Y is equal to 2x minus 5. And let me just work it for those who didn't see how we got the gradient. Remember, the products of the gradient of perpendicular line is -1. So the product of gradients, so what we expect is that the gradient of line 1 multiply by the gradient of line 2 should be equal to -1. So the product of the gradients of perpendicular line is equal to -1. We know the gradient of line 1. We got it as -1/2. So it is -1/2 multiplied by the gradient of line 2 should be equal to -1. So in solving for line 2, the gradient for line 2 is line 2 is equal to -1 divided by -1/2. And when you do that, put that in your calculator, you'll get the gradient of line 2 to be 2. So that is how we got this 2 right here, by working this out. And you don't have to work it out. As we said, we know that the gradient of one line perpendicular line to the other gradient, it would be the negative reciprocal of it. So you're looking at -1/2. The negative reciprocal of this would work out to be a +2. So you didn't even have to work it out because you know the theory. So you could have just went ahead and stated it. The gradient is 2. We can put that in our formula. So therefore, the equation for line 2 is y is equal to 2x minus 5. Any question? So someone had mentioned functions up above. Now we are going towards function. So this says determine, and I look at function as just an advanced form of substitution. And you'll see why, because this says, given that f of x is equal to 1/3 x plus 4 and g of x is equal to 3x being divided by x plus 1, they want us to determine the value of f of 9. So what this is telling us, in this function of f of x, everywhere that you see x, you will replace it with 9. So that is basically what function is doing here. That's why I say it's just an advanced form of substitution. So in looking for f of 9, all you're doing is that everywhere in this f of x function that you see x, you will replace it with, in this instance, the number 9. So can anybody, before I work it out, what would that be? Answer is 7. Very good. So you're doing 1/3 x. Wherever we see x, we're going to write 9. So it is 1/3 9 plus 4. We can do some amount of canceling here. So 3 into itself goes 1 time. 3 into 9 goes 3 times. So what we have here is f of 9 is equal to 3 ones, 3 plus 4, which would give us 7. So f of 9 is equal to 7. Any question before we move on? So f of 9 or g of -3, you're taking that to put it in the f of x function. So first work out g of -3, and everywhere in the f of x function that you see x, you'll put the value for g of -3. So you're putting this into the f of x function. So that is how I look at it. So first, what I encourage students to do, work out this portion, the g of -3. So when you work g of -3, what do you get? So when you work g of -3, I'm seeing 6. No, go again. So remember, our g of x function is 3x over x plus 1. I'm seeing 9 over 2. Very good. That is what I got, 9 over 2. So you're doing 3 being multiplied by -3 divided by -3 plus 1. So 3 times -3, that will give us -9 divided by -3 plus 1, that will leave us with -2. So -9 divided by -2, and that will give us 9 over 2. So this is our answer for g of -3. Now in the f of x function, wherever that we see x, we're going to replace it with g of -3, and we know that g of -3 is 9 over 2. So wherever in the f of x function that you see x, you will replace it with 9 over 2. So what that will look like is f g of -3. Everywhere that we see x, we're going to write 9 over 2. So it will become 1 over 3 being multiplied by 9 over 2 plus 4. Yes, very good. I'm seeing the answers in the chat. Very good. So therefore, f g of -3 is equal to, so if we do some amount of cancelling, we could have said 3 into itself. So 3 into itself goes 1 time. 3 into 9 goes 3 times. So what we have is 3 over 2 plus 4. So let me do it step by step, because I could just say put it in a calculator, but 3 over 2 plus 4. Now you're working this out. And when you work this, that is how you will get the 11 over 2 as the final answer. You can look at it as 2. If you put it in a calculator, by the way, 3 over 2 plus 4, it will give you your answer as 11 over 2 or 5.5. If you choose to work it out on your paper, you are finding the LCM first, because remember, when it comes on to adding fractions, any way that you choose, whether the easy way, the hard way, or LCM would be 2. 2 into 2 goes 1 times 1 times 3 is 3. And then 1 into 2 goes 2 times 2 times 4 is 8. And that is how we now get 8 plus 3 will give us 11 over 2, or it's the same as 5.5. So FG of negative 3 is equal to 11 over 2 or 5.5. Any question? So that is it for that function, just advanced substitution. Part 3, yes, CJ?
So, sir, it would be easier if you put the formula in the bracket instead of worked out first and get 9 over 2.
You can do it that way. You can do it that way, CJ. You'll get the same answer. But I wanted it to be as clear as possible for those who weren't as privileged as you were to have a good teacher. So I want to ensure that they understand. Go over the second to last line of equation, second to last line. So what we basically have here, Jordan, is just 2 fractions. So if you put in your calculator 3 over 2 plus 4, you will get this final answer. But for those who probably, let's say you're in the exam, your calculator stopped working, but you remembered in working fractions. So it is 3 over 2 plus 4, which is the same as 4 over 1. So all I did here was to treat them as 2 fractions, find our LCM because the denominators are different. So LCM is 2. I say 2 into 2 goes 1 times 3 is 3. Plus 1 into 2 goes 2 times 4 is 8. So therefore 8 plus 3 is equal to 11 over 2, which is the same thing as what we got in our final line. Good, Jordan? All right, very good. So now the last line, but yes, CJ, you could have just went ahead and put, so what you'd have done is wherever in f of x that you see x, you replace this entire, all of this working that you did first, it would have been everything that would have come in this bracket. So all of this working out would come in this bracket. You can do it that way, but this is just a step-by-step approach. Part 3 now says, determine the value of x for which g of x is equal to 5 over 2. So now what they're telling us is that g of x is equal to 5 over 2, and they want us to solve for x. So what this will look like is if g of x is equal to 5, very good. So you'll have 5 over 2 is equal to the function that was given, which is 3x being divided by x plus 1. And what we're doing is solving for x here. So what I did first was to change that fraction out. 5 divided by 2, I get 2.5 is equal to writing back everything 3x being divided by x plus 1. And now I'm going to work as best as possible to try and solve for x. So let's go on this journey. So x plus 1, I'm going to first remove this x plus 1 from here. It is dividing here, so when it comes across the equal sign, it will be multiplying. So it's the same as I'm multiplying both sides of my equation by x plus 1. So what we'll get is 2.5 being multiplied by x plus 1 is equal to 3x. We can expand our bracket here. So 2.5 multiplied by x, that will give me 2.5x plus 2.5 multiplied by 1, that will give me 2.5. Now on equal to 3x. Now on to basic algebra. Sorry about that. So now on to regular algebra. We know that next we group or like terms. So I'm going to say 2.5 is equal to 3x minus 2.5x. So the 2.5 here, it was adding. So when I carry it across, it is subtracting. So I get 3x minus 2.5x. So when we work that out, 2.5 is equal to 3x minus 2.5x. What we'll get is 0.5x. And now we can solve for x. So it is 2.5 divided by 0.5. 2.5 divided by 0.5. And that is equal to x. Yes, Renisa. So when you do that, you'll get 5 is equal to x. So it's just working your equation in a step-by-step approach. So for right here, remember the 0.5 is multiplying. So we're basically dividing both sides of our equation by 0.5, and that is how we get 2.5 divided by 0.5 is equal to x. And when you put that in your calculator, you will get 5 to be your answer. So when g of x is equal to 5 over 2 or 2.5, then our x value is 5.